I'm always terrible at starting videos. I'm like the worst.
That's a great start.
Yeah, I know, right?
Here's another video I suck at.
Exactly. I really suck at opening videos. But you know what I am good at? Fixing amps, fixing guitars, and fixing all that. So, of course, here we are in the Dr. Gear repair shop. We've got a Peavey 6505, aka the 5150 Mark I. Yes, they're identical amps. No, there's nothing different between them beyond the regular changes that you'll get in manufacturing runs with components. They still use the same PCB that they always have since the original ones launched way back in the early 90s. One common fault that does happen with these, and it also happens to things like the Mesa 290 power amp and a whole bunch of others that use these big, massive, hefty, current-sucking tubes, is that suddenly the output tubes stop lighting up. There's no power, there's nothing like that. And the reason why is because of these little connectors here. Really, really easy to use for, manufacturing, all the rest of that, plug and play, done and done. But what happens is that is scorched, that is burnt, that is dead. And the reason why is because you've got 4 6L6s here, right? Each one pulls about an amp's worth of current. So when you've got an amp of current being pulled through that connector, any little change in how much is contacting the pin or anything else like that is going to cause a massive, bottleneck for the current to get through. So heat is going to be generated. Get a smaller piece of wire, run the same amount of current through it versus a thicker piece of wire, and the smaller one is going to burn up. So when we look at this little one here, you can actually see where it's scorched. So it's a cascading failure. All that current, all 4 amps of it, is going through that little section of it there and through that pin. You can actually see the heat damage there. You can actually see it really, really badly. So zoomed in now on this, you can actually see where it's almost welded itself to that. There's heat underneath there, so this could have happened over a matter of seconds, minutes. It could have happened multiple times, which is why that's sort of gone off. This kind of failure will continue to happen whatsoever you've got these quick connectors. So what we need to do is get rid of this and actually hardwire from that board to this board, at a minimum, those heater runs. Doesn't matter so much about the high voltage stuff, doesn't matter so much about anything else on that board, because that's why we run higher voltages through our power lines, because when you've got higher voltage, you can have lower current, which means that you're not going to have to worry so much about it dropping off in the line, and you're going to have to worry so much about heat. So if we get rid of at least those 2 pins there, hardwire them into that board, then that's going to help to minimize that problem in future. Next step is we pull the board out, get rid of those pins, hardwire it in there, and give it plenty of solid contact. On to the next part of the job. PCB now on the bench, all removed. Let's take a look at just how bad this damage has gotten. Over on the back side of the board now, if we look here, we can actually see those traces, and what they do is they flood fill them with extra solder so they leave them unmasked, and that way you can actually increase the current carrying ability of those traces. So you're basically taking like a 1 ounce or 2 ounce copper trace and turning it into the equivalent of like a 10 ounce trace. So they did really well there, but then they screwed up with those pins. If we look really, really, really close, let's see if this is going to focus. Come on. Focus. Focus. Nah, not going to focus. If we look here, this has actually reflowed the solder. It's gotten that bad. The heat there got so much that actually reflowed. So let's get these pins out and let's wire up some proper heavy gauge wire and get a hardwire connection going on. So this must have been a Friday amp, because if we look really, really close here, you see that right there? No solder, no solder. There is so little on that is just, wow. A solid vibration could have even knocked that loose and caused some crazy intermittence. We've actually touched up quite a few solder joints now on this amp that have been that bad, so we'll continue to keep going through them and get it back in the box once I've dealt with them all. So we were reassembling the amp, and we had a screw that was giving us a bit of difficulty. It almost felt like the standoff was spinning while we were trying to get out. But it was something actually a little bit more strange. It's a screw that was installed at factory that never had a thread. What? All it would have taken is one wrong move and that to come flying out and short out something inside of the amp. I've never seen this. Let's continue putting this back together and see what else there might be sort of funky going on. Wow. Alright, so board's back in, ready to rock and roll. 2 hardwired connections there. I need to get rid of these 2 pins. So, let's do that. Cool. There's done, there's done. Alright, heat it up. Then grab with that. I'm going to minimize how much of a heatsink effect happens. Come on. There we go. Pin 1. Heat that on up. Come on. I'll see you there. There we go. Pin 2. And we'll just quickly remove the excess solder so we got some put some fresh stuff on there. Nice. Alright. Got some nice hard line connections there. Right there. And we'll get that in there nicely. Come on. There we go. And we add our nice little bit of fresh solder. Just like so. Nice. Get that one out of the way. I can go down a bit. Same deal. Nice bit of fresh solder. Get a proper hard connection going. There we go. And so now, that should cause very, very few problems going forward, because now we've got a hardline connection going between those 2 boards. Might mean that if it comes in and it needs to come out again, might be a little bit more fiddly to get it out, but you know what? That's okay. As long as that is held together properly and as long as there's enough current capability in that, it's not going to short out in the same way. So let's deal with the quick connect, which is the next part, and then we can start testing it. Cool, so now we've redone these. Trimmed down those connectors so they fit nicely. Nice hardwire connections there. Everything's all reconnected. Good to go. Touched up all those ganky solder joints. Now we get to do the fun part, which is power it up. So what we're going to do, just to make sure things are all nice and safe, is going to power it up. Old-fashioned variac there. Make sure there's no shorts, nothing weird going on, nothing along the lines that could possibly damage the amp, or even more importantly, us. But now, if we actually look at one of the pins there with relation to ground, look at that, 24 volts above ground. So there's 6.3 volts AC being superimposed over 24, 25 odd volts there. That actually helps to minimize the noise of the output, minimize hum, minimize all of that. It's a really cool way of doing it. But you've also got to make sure that if you actually raise that heater voltage, you want to make sure that there's not a huge difference between the cathode and that heater. Otherwise, you can end up with shorts, and it just ends up as an absolute mess. Sparks flying everywhere. Let's power this down. Let us get some tubes in there. Let's test it again and see how we go. Alright, so let us magnetize that variac a wee bit. Keep an eye on that current. Good. Good. It's about halfway. Let's check those tubes, see if there's any light going on this time. Cool, we got some light going on them filaments from what I can see. Just a wee bit. good. Turn it up a bit more. Cool. Alright, so we're sitting at 300 milliamps. Draw current. Okay, yep. So, yep, tubes are warming up. We got that there going on. So, pre-gain there, that's fine. Channel changing is okay, crunch is okay. So, let's measure the output then. Pre-gain, lead, rhythm, all that. Signal in. Yeah, shiny. One of the worst clean channels ever devised by man. But, you know, you don't buy this for a clean tone. Clean tone. Crunch mode is good. Bright, yep, it's good. Channel. Let's get to the real meat and bones of this. Look at that. Nice. There's a big, fat amount of power there. Clean channel, so everything's switching over okay. Not seeing any arcing, no excess current draw. Tubes are nice and lit up. Good stuff. Let's get this plugged into a speaker, see how it goes. Alright, tubes warmed up, powered up. Even with volume at 0, you still get noise coming through because there's actually a bit of bleed through the effects loop, which is kind of interesting. Clean tone, totally. Bright mode, yep, that works. That's when we crank the gain on that. That's the clean channel, dear Lord. Let's hit it with crunch. Favorite for recording. Rhythm channel, crunch mode. Yep, does what it needs to do, does what it says on the box. Let's go over to channel duh. Short scale guitar is very hard. Good stuff. That's back alive. We'll get that back in its case, and then out the door to one happy customer. Can't quite use it right now because we're all stuck in lockdown, but while we are stuck in lockdown, we are still accepting repairs and all the rest of that. Contactless drop-off, pick-up, all the fun stuff. So while we're bored and we can't do anything, we can't go out and play gigs, you may as well get your stuff sorted. Visit us online, drgear.com.au. Buy some stuff, support us, check out our things, follow us on Facebook, Instagram, all the usual stuff. See what interesting things we come out with. Till next time, peace.